And let's look at this Venn diagram. Okay, so here's what's happened. You've got 30 kids in the room. So the box, we call it the universal set, it's everything. Okay, there's 30 kids in the room. We've taken a survey, and 11 of them like M&Ms, 9 of them like Twix, and what are those 6 right there? What do they like? Both. Okay? Now, how many kids is this altogether? We have 11 and 9 and 6. How many is that?
36.
Okay, but there's supposed to be 30. So where are the other 4?
Don't like that.
They don't like either kind of candy, right? They're outside the circles. They're still in the room, they're still in the box, but they don't like any kind of candy. Okay, here we go. Look, read question A, and then also read question B. You'll see the difference. How many kids like M&Ms?
17.
17. Because don't these kids also like M&Ms? This whole ball is the M&M ball. So the answer to A is 17. The answer to B is 11. How many like M&Ms and Twix? That's these right here, right? How many like either one? M&Ms or Twix? 26, that's right. There are if you like any kind of candy, you count. And there's 26 kids up there that like candy. How many like only M&Ms or only Twix?
20.
That's 20. That's the 11 and the 9. This is easy. You just have to read very carefully. Okay. How many don't like either kind of candy? 4. We already figured that out. Perfect. All right. Now, number 4. Problem number 4. No numbers are in the chart, so you're in the Venn diagram, so you're going to have to put them in yourself. Each of the 28 students in the class either likes jazz, country, or both. Now, if each of the kids likes that, there's 28 kids altogether, and there's 0 out here. Would you agree with that? All 28 like something. $18 like jazz, so the jazz circle is 18, and the country circle is 14. Now, does anybody see a problem with this? There's more people here, so envision this for a second. There's 28 kids in the room. I say, raise your hand if you like jazz. 18 hands go up. Raise your hand if you like country. 14 hands go up. What had to have happened? Somebody voted twice, right? How many people voted twice? You can figure this out. How many hands went up? How many hands went up altogether? 32. How many people were in the room? 28. So how many extra hands went up? 4 people voted twice. 4 people voted for both. Okay? Now, if the whole jazz ball is 18, then how many are here? 14. And if the whole country ball is 14, how many are here? 10. And now you can answer whatever question they want. How many students like only jazz? Isn't that these guys right here? 18 like only jazz. All right, now the next one uses some notation that we have to get used to. Okay, so you can think of A and B as apples and bananas, okay? And this says the probability that someone will like apples is 0.6. And the probability that someone will like bananas is 0.5. This symbol, anybody remember what that symbol means? And, that's the and symbol. So this is the probability that somebody likes apples and bananas. Okay, wait a minute, where would that be in the Venn diagram?
Middle.
In the middle, so this is 0.2. So instead of putting actual numbers in there like 14 and 9, we're putting in probabilities now. So the probability someone likes both is 0.2. Now remember, the probability you like apples is 0.6. That means the whole A circle is 0.6. If you've already marked this with a 0.2, then what does that mean about this?
0.4.
That's gonna be 0.4. And then what about over here? 0.3? Now guys, these are probabilities. What do we know about probabilities? The whole thing has to add up to what? 100% or 1? 100% or 1? So the whole thing has to add up to 1. What do you have in the circles right now? You have 0.9 in there, which means what? There's 0.1 out here, and what are those people? Those are the people that don't like apples or bananas. All right, let's answer the questions. So, all we've done so far is fill in our Venn diagram. Now we're gonna start answering these questions. This little guy right here means not be. So this is, what's the probability you like apples and not bananas? That's what this means. You like apples and not, this means and not bananas. So look at your chart. What's the probability you like apples and not bananas? 0.4. That's these people right here, isn't it? What does this one say then? Don't like apples and you do like bananas. So what's that? That's these guys right here. What's this one? Don't like apples and I don't like bananas. 0.1. Okay? All right, take a minute and try number 6 on your own. It's exactly the same kind of problem. Exactly, just have different letters. So think of it as cookies and donuts. Okay, what you got? You got it figured out? Okay, so C and D, and the probability of C is 0.75, and D is 0.4, and C and D is 0.35. So that's what we always start with, right? Right there, that overlap. And then from that, now we can figure out D. So what's this section gonna be?
0.4.
0.40, yeah, or 0.4. And what's this one gonna be?
0.05.
0.05. Now, what do these add up to?
0.8.
0.8, which means the other 20% is out here. Question B says C and not D. What did you put down as the answer for that one? Right here. See, I like cookies, but I don't like donuts. And then I don't like cookies, but I do like donuts. That is 5. And then D is I don't like either one, not C and not D, and that is 0.2. How many got that right on your own? Perfect. Good job. Good job. Good job. All right. So now we're going to do our last kind of probability. So we've done the charts, we've done the card problems, we've done the Venn diagrams, and now we're going to do what's called conditional probability, and we're going to do it with tree diagrams. Okay, so I want you to read question 7. And would you agree that there are 2 things happening in this problem? We've got issues with raining, and we've got issues with doing homework. Read the very last line, the actual question. Find Joe's probability of doing homework. Whatever the question asks for, that's going to be the second thing you consider. So the first thing I'm going to consider is it's going to rain or not rain. And then I'm going to do homework or not do homework. Now, it's important that you do it in this level. I mean, like this, rain first and then homework. How do we tell what order to do it? The question that's asked is always last. So since the question says find Joe's probability of doing homework, homework is last. Okay? Now, if it rains, the probability Joe will do homework is 0.40. So this little branch right here, so it's gonna rain and he's gonna do homework. That's 0.4. If it doesn't rain, the probability of homework is 0.10. Does that make sense to everybody? Given that the probability of rain tomorrow, so the probability of rain is 0.30, find the probability he's going to do homework. Well, we got to fill a few more things in our chart. Do you have any thoughts on that? All those branches need to have numbers. We need numbers on all those. Eli?
Yeah, you can put 27, that's not.
Bingo! Guys, if there's a 30% chance of rain, then isn't there a 70% chance it won't rain? And likewise, if there's a 40% chance he'll do his homework, there's a 60% chance he won't? And 10, 90? Now the whole chart's filled in. Probabilities of mutually exclusive events have to add up to 1. 100%. Rain, not rain, 100%. Okay. find the probability that he'll do his homework. Now, he could do his homework right here, that's a homework, or here. So he could do this, or he could do this. Who remembers what that or tells me? Since it's this or this, what am I gonna do with those answers? Oh, or is an add. They're gonna get added together. So I'm gonna find this answer. Now, this side of the tree diagram is rain and homework. So rain and homework is 0.30 times 0.40, which is 0.12. Rain and homework, and multiply. Rain and homework. Now this one is not rain and homework, so that's gonna be 0.70, 0.10, or 0.07. What is the answer to the question then? 0.19, 0.19. So there's a 19% chance this kid's gonna do his homework. Okay. All right, what's happening in problem 8? What are the two things in problem 8?
There's,
You got noodles and salad, right? So what's the question? Find the probability they'll serve salad. So that comes last. So we're gonna start with noodles and not noodles. Okay? And then we're gonna have salad or no salad. So again, guys, always make the bottom level, the question. So it says, what's the probability we'll serve salad? That goes on the bottom. All right, let's fill in the numbers. Where does the 80 go? The 80% chance, where does that go? Noodles salad, that's right here, right? We're gonna have noodles, so we're here. There's an 80% chance we'll have salad, which means this is a 20. If we don't serve noodles, there's a 50% chance we serve salad, which means there's also a 50% chance we don't. Given that they serve noodles just once each school week, what does that mean?
it's like a 20% chance.
It's like 1 out of 5, right? So that's a 20% chance. So the probability of noodles is 20%, so not noodles is 80%. And we want the probability of salad. So here we go. Remember, to get down here, you gotta multiply this whole row. So you're gonna take 0.20 times 0.80, which is 0.16. Use your calculator. Or we can come this way, which is 0.80 and 0.50, which is 0.40. And then what do we do with these two numbers? Add them, 0.56. All right? See if you can do question 9. See if you can do question 9.
Yay, lost.
What?
Good.
No, I'm just really tired. Every time I eat this cake noise.
Nice guys, nice guys.
Yeah, I'm weird now. It's like weird.
That's what we started.
So big, it's like,
Are you guys got this figured out? Give me an answer, what'd you come up with, what'd you put first?
Soccer, no soccer.
This is soccer, oh actually, this is soccer and no soccer, okay? Remember, that means not, so I'm gonna use my abbreviation. And then we're gonna have lacrosse and no lacrosse. And did you put .62 and .38 here? And .48, .52 here? And .70 and .30 here, does that look about right?
Yep.
So you are finding lacrosse. So, ooh, I need a calculator here, I need to multiply .70 times .62, or .30 times .48. Is that right? So what does all that equal? .578? Is that right? You don't get that? Perfect. All right, that's it for this little unit. So we are going to, I just went and ran off one of the practice tests for you. Take this in a moment. Leave your phone here. All right, so here's the first practice test. I'll run the rest of them off another time. And they're not stapled. Feel with it. Okay, so here we go.
Normally when you're doing these jobs, we gotta at least add a week.
Okay.
Did I give you one already? Yeah. Okay, does everybody get one? All right, here we go. Answer the following, use your calculator to evaluate, round to the nearest thousand if necessary. Okay, here we go. Remember, the answer to the question will be the actual number. So when I look at problem number 1, how many ways can 7 books be arranged on a shelf? I immediately think 7 factorial. But the answer is not 7 factorial. The answer is 5,040. What 7 factorial equals, right? The number is the answer. Alright, how many outfits are possible if you have 4 pair of pants and 6 shirts? Any guesses? No, I understand where you're coming from though. I would do 2 things about that, Sammy. First of all, when I pick an outfit, I'm picking a shirt and a pair of pants. So there won't be a plus in this problem anyway. It's going to be a times, because I'm picking one of each. And when I say 4 factorial is arrangements. Am I arranging these shirts? No, I'm just going into the closet and grabbing one. So how many options do I have for a shirt? 4. How many options do I have for a pair of pants? How many do I have altogether then? 4 times 6. It's 4 times 6. You're gonna pick you're gonna pick a shirt, and you're gonna pick a pair of pants. Only one shirt, you have 4 options. Only one pair of pants, you have 6 options. 4 times 6. No factorials in that problem. Factorials are when we arrange. How many ways can you answer 8 true-false questions? No, it's not 8 factorial. Stop and think a minute now. Here are your 8 questions, right? Here's question number 1, and it is a true-false question. How many options do I have for question number 1? 2. How many options do I have for question number 2? 2 and 2 and 2. And what do I do with all these 2's? Multiply them, because I'm answering question 1 and question 2 and question 3. So the answer is 2 to the 8th. 2 times 2 times 2, 8 times. Those are options, remember. Options. If those of you that said 8 factorial, this doesn't even make sense in this problem, because 8 would mean you had 8 choices, and you don't, you only have 2, right? How many ways can I give a pencil marker and an eraser to 3 students in a class of 12? 12 C, 12C3 or 12P3? P. Why is it P? Because order matters, right? You have different prizes here, guys. If I were giving away 3 pencils, then it would be 12C3. But since I'm giving away different prizes, order matters, and it's a P. Are you listening to me? This has to register. I have a test soon. All right. How many 8-letter words can be formed from the letters of prettier? Well, aren't there 8 letters in that word? Okay, so start with 8 factorial, because there's 8 letters. I know some of them are duplicates, but it doesn't matter. There's 8 letters. Now, what are the duplicates? We have 2 R's. Oh gosh, we have 2 R's, 2 E's, and 2 T's. Does that take care of everything? Okay, and what, do you remember my caution when we first did these, where they tell you when you go to type this in on your calculator? When you've got all this action in the denominator, you have to have parentheses.
Can you not just like add up all the 2's and then do like 6 factorial?
No, factorials don't combine. All right, and so your answer should be 5,040, I believe. Is that what you got? How many ways can 10 people be seated around a campfire? people seated around, that's the key word, around a campfire. You gonna remember that special little situation? Take one away, it's 9 factorial. So 10 people in a row is 10 factorial. 10 people in a circle is 9 factorial. I don't know what that number is, it's big. Yeah, whatever it is, yeah, that's it. All right, how many committees consisting of 3 boys and 5 girls can be formed from a class of 10 boys and 8 girls? This is like your card problems, only instead of like diamonds and clubs, we've got boys and girls. So, how many boys are in the club altogether? How many boys? There's 10 boys in the class, right? Alright, so there's 10 boys, and I'm gonna pick 3 of them to be on my committee. Does everybody understand why that's a C and not a P?
Yep. It does not matter.
Order doesn't matter on a committee. And times, now I have to pick 5 girls. What's that gonna look like? HC5. Because I know it's been a long time ago, but remember the card problems we did and you were picking clubs and jacks or something like that? Remember, this is what we did. We took 10 boys and picked 3. We took 8 girls and picked 5. And we multiply those together. It is not a probability, so don't divide it by anything. I got 6720. What is the probability of being dealt a 5-card hand that is composed of all diamonds? What is the probability? This is going to be a fraction, and the denominator is going to be 52C5. Why is the denominator 52C5?
Because you're gonna get 5 cards.
52 cards total, picking 5. That's your denominator. Now, all diamonds. What's that? All diamonds.
60.
Not 16.
8.
Not 8.
4. There's 10, there's 4 faces.
13.
13. There are 4 suits, diamonds, clubs, hearts, and spades, right? Since there's 52 cards altogether, 52 divided by 4 tells you how many there are in each suit. This is gonna be one, I cautioned you about this before. This is gonna go to scientific notation, and you've gotta pay attention to that. Because I'm taking no prisoners. 4.952 times 10 to the negative 4th. If you don't put this on the end, you're wrong, totally. Probabilities are less than 1, so 4.95 doesn't make any sense. All right, number 9. What is the probability of a 5-card hand? Okay, starts the same way. Exactly 3 aces. Exactly 3 aces. Any thought on that? Now, it won't be 3C4, it will be 4C3, right? Remember, this is how many you have, and this is how many you're getting. Wait, but we're not done. We're not done. Does anybody see what's wrong with this? This is tricky. How many cards are you supposed to have in your hand? 5. If 3 of them are aces, then what?
2 of anything else.
The other 2 are not aces? You gotta have 5 cards, kids. Right now, you only have 3. So how many cards are not aces in the deck? 48? And you wanna pick 2 of them. What makes that tricky is, the problem doesn't talk about these cards. You have to think about that. There are 5 cards altogether. 3 are aces and 2 are not aces. What would we get for that?
It's true.
I got .00174, is that what you got? Ooh, what about number 10? Does that look familiar?
Yeah.
What is gonna be our strategy with number 10? What are we gonna build?
True.
A tree, the pyramid, that's right, a tree diagram. And what's gonna go on the bottom of the tree diagram?
If you will play tennis, right?
Tennis, right, so we're gonna have rain and not rain, and then we're gonna have tennis and not tennis. Remember, that little hash mark means not. So you can either write the words, I'm kind of cheating here a little bit using my notation, shortcutting, I should say. All right, if it rains tomorrow, if it rains, the probability I'll play tennis is 0.15. Which means this is 0.85, because these have to add up to 1. If it doesn't rain, the probability I'll play tennis is 0.90. And the probability of rain is 0.45. Now I want everybody to look at that picture and make sure you understand where all those numbers came from. Okay? Now, what do I want to know? Probability I'm going to play tennis. So I have this whole branch. So 0.45 times 0.15. Or this whole branch, 0.55 times 0.90. Remember, on the branch, you multiply rain and tennis. Not rain and tennis. But it can be either situation, so that's an or, and you add those two together. Did you get 0.5625? We got 50 seniors in the chapel. All of them enjoy singing or praying. If 25 indicate that they enjoy singing and 32 indicate they enjoy praying, how many enjoy only praying? What? Make a Venn diagram, perfect. Doesn't it just feel like a Venn diagram? You got people doing this or this and overlapping, so it just feels like a Venn diagram. So here we go. We got people in there, and they are praying and singing. And praying is 25.
Probably.
No, praying is 32. Singing is 25. And there's 50 altogether. And every single one of them likes one or the other. So there's nobody out here. Everybody's either singing or praying. Okay. Tell me what you notice about the situation.
7
Yeah, this is too many. This is 57 kids, and you only have 50, which means 7 of them did both. since the whole praying circle was 32, what is that, 25 here? And 18 here? And what was the question? How many enjoy only praying? Only praying would be 25. All right, here we go. Who remembers anything about this?
I know it's a really,
What?
that's just a really long answer.
It's gonna be a long answer because you're foiling that out 4 times.
So you know you're gonna have.
So we're gonna use Pascal's triangle to get our coefficients. That is the numbers that we write down, that's step 1. So remember, Pascal's triangle has a 1 and a 1. And then starts and ends with a 1, and the numbers in the middle are the sum of the 2 above. Okay, remember this deal, guys? Remember doing that the other day? And I'm gonna stop there because this is the 4th row, 1, 2, 3, 4. And that's the row I need when that power is a 4. The power tells you which row. So I'm gonna write down those numbers, 1, 4, 6, 4, 1. Okay, good, that's step 1, get those coefficients down. Now, who remembers what we do next? What do you like?
Count down variables.
Well, but first, let's get the variables in the problem. So first, I'm gonna go through, and I have an x and a negative 2y. So x, negative 2y, this is a multiplication, it is not a subtraction. It's x times negative 2y. X times negative 2y, x times negative 2y, x negative 2. Then Eli will do what you said, which is put on the exponents. Remembering that the first term, x, goes to the 4th power and then counts down all the way till it gets to 0. And then what about the 2y part?
Because,
It goes the other way. And each term, notice that the exponents in each term have to add up to that one, right? So you're right, they all add up. Okay? I'm gonna put plus signs in there, this gets a little crowded, especially if you haven't given yourself enough room. And then you simplify, you multiply everything here. Now, what is anything to the 0? No, no. Anything to the 0 is 1. So this is like multiplying by 1. So I'm gonna just cross it off so it doesn't confuse me. That's a 1. So what's my first term? X to the 4th. Now, in the next term, this is all multiplication. So you are multiplying a 4 and a negative 2. So that's going to be negative 8, x cubed y. This is all multiplying. There's no subtraction in there. Well, there's subtraction in front. But that is one term all multiplied. Here is where we run into trouble. Remember that the exponent goes on everything inside the parentheses. Okay? So the exponent goes on the -2 also. What's -2 squared? 4 times 6 is 24. And it's positive because -2 times -2 is a positive number. Same thing here. What's gonna happen here? What's this right here? -8? -2 times -2 times -2, it's gonna be -8 times 4, so it's gonna be -32. And what about the last one?
-2 y to the fourth, or no?
Plus 16 y to the 4th. Everything that's the exponent. So -2 to the 4th is positive 16. Is just like that, except you're not doing the whole big long thing. Ellie said, I know this problem's really long. That's all she wrote. Well, it is really long, but not this part, not the next one, because we are only doing one term. We want the third term. If we were doing the whole thing, which row of the triangle would we need? We would need a 7th, right? So I'm gonna go ahead. I'm just looking these numbers down. Remember, we start and end with a 1, and then we add. So this is gonna be 6, 15, 20, 15, 6, and 1, 7, 21, 35, 35. Now, I need everybody, you have to be able to do that on your own. You okay with that? Everybody see where those numbers came from? Now, we want the third term, so that means we only want the 21. That's the third term. And next to that 21 will be a 2x and a y. Now I need my powers. Well, how did we do our powers before? Counting down. So if we were doing the whole row, my 2x power here would be 7, and then 6, and then 5. So my 2x power is 5 just by counting down. And if that's a 5, what's this one gotta be? 2, because they gotta add up to 7. Now we're simplifying. So then I'm multiplying. 21 times what? What's this? 32. So 672 x to the 5th y squared. So we do exactly what we did with all of these, but we only have to do it once. All right, you guys have been great. We're gonna do one more, number 14. How do you calculate HC5 by hand? Who remembers this? There's like a little formula. You remember, Clark? No.
It's like 8 over 7.
It's 8 factorial over 3 factorial and 5 factorial, yep. So, 8 obviously is this number. And then where did the 3 come from? Subtract, and then the second number. Now remember, 876, and then everything after that's gonna cancel with this. And this is 321, which is 6. I think the answer is just 56. Done by hand. Alright, we will pick up there tomorrow. And I'll have the rest of your practices run off for you.